Welcome, Math 13 students. We have some examples from section 7.1, estimating a population proportion. We're going to go ahead and use a given interval to find both the point estimate p hat and the margin of error e. And then we'll take a look at an example where we actually construct a confidence interval. So let me go ahead and share my screen. And we'll get going. All right, chapter 7. Confidence interval, basic examples. So we're going to review the notion of a confidence interval. We'll identify the point estimate and the margin of error in a given confidence interval. Then we'll go ahead and construct a confidence interval for a population proportion. And we'll take a look at some appropriate examples as we go through the material. Some basics. Well, a confidence interval estimates a population parameter, and it contains a range of values. And it has an associated probability called the level of confidence. Now, this level of confidence, it's the probability that the range that you find actually contains the true population parameter. And the probability is set by the choice of the level of the significance alpha. This is the probability of seeing either a significantly low or high number of outcomes. The level of confidence is given by 1 minus alpha, and there's some very common values that are used very frequently. 90% or 0.90, 95%, 0.95, and 99%, 0.99. That's your level of confidence. 90, 95, 99 are very common here. Some more basics. Now, the confidence interval contains basic data about a sample and the amount of potential error in the estimate. And the confidence interval for a population proportion can be used to find the point estimate p hat and the margin of error e. And my first example is going to go through the detail there. So here's example 1. We have a political research analyst at a local university. We have a 95% confidence interval for the proportion of people who say they will vote in the next election. 0.65 to 0.87, that's the level of confidence, or the confidence interval. So we want to find the point estimate and the margin of error. We're going to need p hat plus or minus e. Basically, all we need is a picture and some simple math. So let's go ahead and take a look at this. A drawing really does work well. So let's see how the drawing looks here. There's your confidence interval. Now, in this particular case, those are the values in question. I need the point halfway between. Add them together, divide by 2. There's my point estimate, p hat. Now, margin of error. High minus middle, 0.11. And there's my margin of error. Now, I can go ahead and put those two together and write it as a p hat plus or minus e, and that's how the big boys and girls do it. So, point estimate, 0.76. Margin of error, e equals 0.11. Now, let's talk about a confidence interval. So, when we build our confidence interval, we're going to need to locate data, a little bit of detail in the problem, and then the correct tool to construct the confidence interval. As far as the data goes, we need to locate x and n. Sometimes they're given, sometimes we got to do a little bit of work. Detail, level of confidence. I'll need that for my calculation. And then the TI-84 tool is the one prop z interval. All right, so let's see how this looks. We have a random sample of 3,005 adults. 81.7% said they use at least one prescription medication. We got a couple of questions. How many of the 3,005 subjects used at least one prescription medication? This is kind of an extra step. This is a little bit of work we have to do to develop X. Then once we have that, we can construct the 90% confidence interval for the adults who used at least one prescription medication. So, how many of those 3,005 used at least one medication? This is an example of your basic percent model. A% of B equals C. In this case, 0.817 times 3,005 is equal to C, 81.7% of 3,005. And you'll note that I converted the percentage to a decimal format. However, when I make my calculation and run it through the calculator, I get 2,455.085. I can't use that number. I need a nice whole number for the number of people who use at least one prescription medication. No partial people here, so I'll round that appropriately to the nearest whole number, 2,455 out of the 3,005. It's a little bit of extra work that often is not needed. X is usually offered up directly. So we want to construct the 90% confidence interval for the adults who use at least one prescription medication. Now, the tool we use is the 1 prop Z interval tool. So let's see how that looks. Way over under tests, it's down pretty far. 1 prop Z in, there's my X, there's my N, level of confidence, calculate. It truly is that straightforward. So, my confidence interval, 90% confidence interval for the proportion of adults using at least one prescription medication is given right there. You'll notice I rounded it to 3 decimal places. There's no hard and fast rounding rule, but I usually choose 3 decimal places. A little bit of analysis and then we're done. So, the statement, the 90% confidence interval for adults using at least one prescription medication is 0.817 plus or minus 0.012, or 81.7% plus or minus 1.2%. There you see the point estimate of 81 and change, and then the margin of error 1.2%. I did place this in the p-hat plus or minus e format using the techniques early in the presentation. Now, what does it really all mean? Well, if I do the sampling and construction 100 times over, about 90 of those intervals will contain that true population proportion. However, we don't know which 90. Honestly, it's a bit of a bet, but it's a good bet because of the central limit there. So, we reviewed the notion of a confidence interval. We've identified the point estimate and the margin of error from a given confidence interval. And we built our own confidence interval for a population proportion. And we took a look at some examples while we got all done doing that. That's the end of this presentation. I'll stop my sharing. I'll say goodbye. Goodbye.